Welcome to Physics Class Question 2, the experiment with the mass 8.5 kg stationary rough surface and with the mass hanger there, and then the crate, and then light inextensible string with pulley. That's the pulley there. And then we have mass added there, so we have different mass added, and we need to calculate acceleration, and experiment is repeated. Air friction resisted, ignored actually. And then that's acceleration there, the vertical axis, the horizontal axis is mass, and we are required to define static friction. So static friction actually is a force, and that's a force that opposes. Okay, so we know that that force opposes, so it actually opposes the movement, okay, opposes the tendency. All right, so which means whatever tendency it has to move, the static frictional force opposes it, so it doesn't have to move. So with the force that opposes the tendency of motion of a stationary object. So the object has to be stationary for it to be static. If it moves, it's no longer static. So it has to hold the object together. And then you know that in reality, static, we have two types of frictional forces. We have static and we have kinetic. So kinetic deals with moving, so this one here actually tendency of stopping the object from moving. So when it moves, it's the static chain conveys to kinetic. So free body, we have the right there tension, the left is friction. So that's our free body there, so that's our tension, and then that is our friction. So that's for the second question. That's the free body diagram. Coefficient we look at T, and then we look at weight, and then we need to know that we have acceleration there, and we have O, we have O there, which is 0. That's the point of origin. And then we look at the information at 4.2. the acceleration is 0, and then we know that at that point the object is not moving, and that's the maximum point at which it's not moving. After that the object starts to move, so mass is 4.2. And then we have friction, static, not kinetic, static, and that's the static coefficient multiplied by normal force. Okay, so we'll have to know that weight. So we have the weight of the 4.2 kg. So weight is our mass is 4.2, and multiplied by that's kg. So we're gonna multiply that by 9,8. That is going to be use a calculator. We have 4.2 multiplied by 9.8, and our answer is 41.16. So that's 41.16 newtons. So that's the weight. So that's also equivalent to tension, equivalent to static friction, and then from there we know that we need to have let's be honest, we need to have, okay, we have two forces there, which is the normal force, and then that is the weight. So we know that this equation, static friction is equals to coefficient of static multiplied by normal force, and our weight there is our mass actually is 8.5 kg. It has to beat normal force, so that's going to be coefficient of static 8.5 multiplied by, to get it to weight, that was mass there, it's not weight, it's mass. So to make it weight, multiply by 9,8, and then we're going to see the static coefficient is going to be 41.116 multiplied by 8.5 multiplied by 9.8. From there we know that we just calculate 41.16 divided by 8.5 multiplied by 9.8. We get 0.49. So when we have 0.49, That's the static coefficient. So the next part, magnitude of the acceleration represented by y. Static coefficient is greater than static kinetic, just like frictional. Static is actually greater than frictional kinetic. And then from there, what we do there, we're going to say, okay, so we have system. So we have to look at the system. That we have, the system is composed of two components. It's the crate, and we have the mass of the hanger. So those are the two parts that constitutes a system. From there we have the crate, and that's our crate there. And then from our crate we know force net is equals to MA. So our force net is equals to tension minus frictional kinetic, actually, because it's moving. And then kinetic frictional force is going to be kinetic coefficient multiplied by normal force, and that's going to be 0.4 we are given, multiplied by our normal force is 8.5 multiplied by 9.8. so that will give us 0.4 multiplied by 8.5 multiplied by 9.8 will give us 33.32 newtons, and that is kinetic. And then from there we know that we have tension minus 33.32, which is the friction, is equals to MA. So we know that mass there is 8.5, then that is going to be 8.5 A. And then from there we equate it to equation 1. So we just let that going to be equation 1 for one part of the system, which is the crate. And now we have to know another part, which is the mass of hanger. The mass of hanger, we're gonna rely on the graph for that. So the graph, that's our weight, that's our tension, and then looking at weight minus T is equals to MA. And then we're going to look at the graph. Weight is 7.4, so that is going to be 7.4, our mass 7.4 multiplied by 9.8. so we always take the mass multiplied by G to give us the weight. So it's minus T is equals to weight, our mass is 7.4, and then acceleration is A, we don't know it yet. Then 7.4 multiplied by 9.8 gives us 72.52 minus T is equals to 7.4 A. Yeah, then from there we can equate that to equation 2. Alright, and now what we're going to do, we're going to say that, okay, so we now have T minus 3.32, that's our equation 1, is equals to 8.5 A. That is equation 1, that's supposed to be A there, and then we have T there, negative 2, put negative T, and then we have 7.72.52 positive, we put it on the correct order, and then we have 7.4A, that is 8.5 A there, and then 7.4 A, that's our equation 2. And then from there we add like terms, so that gives us 0T, so we're not going to include 0, it disappears. And then we add negative 33.32 plus 72.52 to give us 39.20, because it's 2 decimals, and then 8.5 plus 7.4 will give us 15.9, so that's A, 15.9 A. And then from there we have to solve for A. So A is going to be 9.20, divide both sides by 15.9, so that's 0. So look at the calculator once again. 39.20 divided by 15.90 gives us 2.465, so it's 2.47. Okay, so a unit is meter per second squared. So that's our value for acceleration, and that's our answer. The next question, the last one, says if you add 5 kg, what will the static frictional force be? Okay, static friction force, is it increasing, decreasing, or stays the same? It's going to increase. And why does it increase? Because static frictional force is direct proportional to normal force. That's it. So increase the normal force, you increase the static friction. And normal force increased by weight as well. So more weight, more greater normal force. Thank you so much for watching. Don't forget to follow, subscribe, and this is your tutor Black Adam.